All right, let's get this started. See if we can pull up the chat window. No, I don't want to sign into iTunes. All right, I'm just getting set up here. We'll start here soon. If you're watching, could you say something in the chat window just so I know how many people's watching? Turn that volume down. All right, just go ahead and get started here. Hello, welcome to the first live subnetting practice session by the TheSubNetwork. I'm Matt. I'll be hosting this today. It's my first time ever doing anything live streaming online. Normally, I teach in person in front of a class, so might be a little bit of a learning curve here starting off, but we'll see how it goes. All right, just a little short introduction about myself. Like I said, I normally instruct in front of a live classroom, and I'm currently in the military. I've been in the military for 12 years. Started off just using computers, kind of worked my way into the technician side, and did that for about 5 years, working on everything from telephony, which is telephones, to networks and desktop troubleshooting, a little bit of cabling, or actually a whole lot of cabling, and a whole bunch more, everything. They don't like to specialize too much in the military, so we kind of do a little bit of everything. After doing that for a couple years, I got transferred, and I've been teaching for about 2.5 years now. I teach one of the units in a about 6-7 month long course, and we take people with pretty much all different types of experience, all the way from never even using a computer to all the way to master's degree in computer science. We put them through a 6 month course and graduate them competent technicians at the end. I started off teaching A+, and that was a CompTIA A+ class. Then I moved on into teaching a cabling class and fiber optics, basically how to run cable, how to terminate fiber, just really basic stuff. And then from there, I moved on into a networking style course, or geared towards the CompTIA network certification course, where the students at the end of the course take their Net Plus certification exam and hopefully get certified. I currently hold a CompTIA Net Plus certification and a Security Plus, and I'm working towards my Cisco. So I haven't really been focused on certifications throughout my career until recently. The military started mandating that you have certain certification qualifications to meet certain admin roles. So we've kind of adopted and started doing the CompTIA certifications. All right. So that's enough about me. Let's actually get to what you guys probably came for, which is learning a little bit about subnetting. So today I'm gonna briefly talk about IP addressing, and then kind of briefly talk about subnetting, and then kind of show a shortcut method for rapidly or quickly subnetting during an exam. So it's the method I've shown students. We used to teach about 3 different type of methods during the class, and then we kind of found out that students get really confused and would mix the different methods. So we kind of worked for a couple months and found the best method for testing. That's the quickest, easiest to learn, and we kind of just stuck with that. All right. So talk a little bit about subnetting, or IP addresses, really. So an IP address is just a 32-bit number or an address that addresses a computer. Normally it's expressed in dotted decimal format, which, it's 32 bits long, and they separate it into 4 chunks or 4 octets of 8 bits apiece, and then its IP addresses are normally expressed in a dotted decimal format. So you might see something like 192.168.2.34 would be an IP address. Or you might have seen something like .0 is a network address, and we'll get to what a net ID or a network address is a little later. So IP addresses are separated they're divided into 2 separate sections. So you're going to have your network, which is the first part of the IP address, and then your host portion. Now, it's not always halfway down the middle or the last quarter or whatever. It kind of changes. There's IP addresses have they're kind of classified into different classes. And those classes decide where the default line split is. But if we just back up a little bit and we have the network portion and the host portion. The network portion, I like to use the analogy, network portion is kind of like the zip code. And the host portion is kind of like the street address, right? So the network portion of the address is used for routers when the information is traversing long distances or across multiple networks. And each router in between kind of looks at this network, the network portion of the address, to get it to its final destination or to its final network. And I always teach an analogy that the network portion is like a zip code and the host portion is like a street address. So if you're going to send a letter from New York City all the way to Los Angeles, and you send it all those post offices in between New York City and Los Angeles that letter is going to pass through, and the sorting facilities and everything are kind of like routers. And when that letter is going through those post offices and sorting facilities, they're just looking at that zip code portion. You know, they're not looking at the full address. They just want to know generally where it goes, what area of the country or what network it goes to. And that zip code is going to be used to route it all the way to the Los Angeles area to that last post office, and then that last post office is going to utilize the host portion or the street address portion to get it to your house or to your device. So that's kind of a good analogy. I like to look at it as the network portion and the host portion. Now, you might be thinking, well, how do I find out what portion of the address is a network portion and what portion is a host portion? Let's say we have an address here. Let's say 192.168.2.0, just like the one that, or let's do the .34. Just make it a device, and let's bump that up a little bit to 28. So we have our IP address here, and if you look at the first octet here, that's going to tell you what class of address it is. So IP addresses are divided up into classes. There's actually 5 different classes: class A, B, C, D, and E, but D and E are used for, D is multicast, multicast, and E is used for research, right? So for the purposes of this video, for subnetting, we don't even bother with D and E, right? Only AB, classes A, B, and C are actually assigned to devices. A class A address, that first octet, is either going to be between 126. So not that. So class B is going to be from 128 to 191. A class C is going to be from 192 all the way up to 223. All right, so this address here that we're going to be working with, this 192.168.2.34 address, is a class C because it fits between 192 and 223. So it's actually that first number there. Now, the classes are important because that tells us our default subnet mask. So what is a subnet mask? Now, sometimes you'll hear a subnet mask be referred to as a subnet mask address, and that is 100% incorrect. A subnet mask is not an address. It just happens to share some common characteristics with an IP address in that it's 30, here, let's go back to yellow, so that it's 32 bits long, and it's expressed in the dotted decimal format, right? And the subnet mask is a continuous string of ones followed by a continuous strings of zeros. So you might have seen a subnet mask wrote something like 255.0.0.0. Now, each of these octets here, just like an IP address up here, is 8 bits long, or a byte. So here with this 255 is actually 8 ones. 1, 2, 3, 4, 5, 6, 7, 8. And then followed by, let's take away that dot, followed by, how many zeros do you think it is? If you have 8 bits here and a subnet mask is 32 bits long, that that leaves you with 24 zeros. So I'm not going to draw out all the zeros, but if you go all the way to 24 zeros there, and is what a subnet mask is used for is all the ones in the subnet mask. If you were to convert both this IP address and subnet mask to binary, and you put the subnet mask on the top, or IP address on top, subnet mask on bottom, and you were to do what's called a bitwise AND, all the ones is the network portion, all the zeros is the host portion. Now, when I teach subnetting, I don't like to go too far into binary, because most students, especially if you're just starting out and I start throwing up binary numbers up there, people start getting intimidated, scared. It's a lot of ones and zeros. But the method I'm going to show you is you never have to convert to binary. It's going to be very, very quickly. I plan on showing different methods maybe in the future. Every probably Saturday, Sunday, I'll be posting it up on Reddit and eventually Twitter and all that social media. And we'll do these study sessions about every weekend. And I plan on going through and making daily subnetting practice questions. But we'll get to that towards the end. Anyway, back to this IP address or subnet masking, right? Each class of subnet mask, or each class of IP address, has a default subnet mask, right? So class A is 255.0.0.0, right? That means in a class A, the first octet is the network, and the last three octets are the host portion. Class B is 255.255.0.0. And a class C, you've probably seen this simple pattern, 255.255.255.0, right? So this address here, being a class C, our subnet mask tells us that these first three octets, that's our network portion of the address. So that's like our zip code. And then the last octet is our host portion. So when routers are passing this packet throughout their networks and they're looking at their routing tables, they're not looking at that .34. They're looking at 192.168.2.0. They're trying to find that network. Now, kind of going a little fast here at the beginning, because I've noticed that the best way to kind of understand subnetting is just kind of do a bunch of questions, and eventually it just clicks. Just as the math is easy, it's kind of understanding it that's sort of the difficult part. But now let's kind of look at a subnetting question real quick. So let me get rid of all what we have here. Clean slate. And let's look at kind of a simple question, right? Let's say that you're a network administrator and someone, hire a network administrator, whatever, your boss, whoever, gives you an IP address 192.168.3.0 or a network, and with a default subnet mask of 255.255.255.0, and they want you to create, let's say, two networks out of that, or two subnetworks out of that, because this is one network. So if it's classful, if it's a full class C address like 192.168.3.0 with the default subnet mask, then that's actually a network. And then when we start chopping that up into chunks, that's where the subnetting portion comes in. So I like to think of a Class C network like this as kind of like a piece of or a big pie, right? So here, let me get this up out of the way. So here we have a piece of pie, right? And it might be hard to tell on your screen, but it's divided up into 256 even pieces or even chunks. And each of these slices of pie represent a IP address in that network. So we know that the host portion here, that is 1 byte, and just with the knowledge of binary math, 1 byte or 8 bits is 256 different combinations or 256 addresses within that network. So if we have, let's label all these slices. We're not going to label all of them, but let's say this first slice is our .0, and I'm just writing the last octet. And then that next slice, .1, all the way 2, 3, all the way down, and right here will be your .64 slice. So 0, 64. If you go down here, this is your 128 slice, and 192, all the way up here. If you were to count, since we started at 0 and there's 256, this chunk, let me do a different color. This chunk right here will be .255. Now, when there's two different addresses that are always not really wasted, but not assignable per network, and those addresses are the net ID or the network address and the broadcast address. Now, the net ID or network address, that's what the routers are using, or those post offices are using for your zip code to get that packet to that final network, so that default gateway can get it to the final host. And the broadcast address, if you've been studying networking, you know that a broadcast message sends out a message to everybody on your local network. So that broadcast is the IP address used to send a message out to all hosts on a network, right? And for subnetting, we're going to take this big chunk of 256 addresses and we're going to split it in half. Why? Because we need two networks, right? Let's say our higher network administrator, all they gave us was this Class C network, 192.168.3.0, and we have 256 addresses, but let's say that we need to split it up to maybe site A or site B. It doesn't really matter why. We just need to split that network up and have two separate networks, and maybe to limit broadcast traffic, or split up those broadcast domains, or just whatever. So we're actually gonna, when you subnet, just classic subnetting, we're not to variable link subnet masking yet, but just through classic subnetting, you can only split it in half. So if we have this network right here, and if we were to split it in half, just like that, we would have two separate networks, so the blue and purple network. And if we wanted to go one step closer or further, you can actually split that network in half further, but you can only keep splitting in halves. So here, this is what's known as a go back to the drawing layer. The /26 network. The one before was the /25. We'll get to what those mean a little bit later when we're introduced to the chart. But that's all you're doing with subnetting. You're just pretty much taking a big chunk of numbers and you're splitting it in half, or splitting it into 4s, or you could even split it up into 8s. So, but that's kind of a really crude graphical representation of what's happening when you're doing subnetting. But let's actually get to a question. If I can move this over here, oh, wrong layer. That's on our question. All right. So let's move this over here. Now, you might, some of you out there might have seen this chart before, but this is the best method I've ever seen of subnetting. So the 10 years before, when I was 10 years my career, I did subnetting the old way, breaking it out down to binary, do the bitwise and all zeros for a network, all ones for the broadcast, and so on. And that's really the slow method. There's no need to go down to the binary, no need to convert a decimal number into binary to do subnetting. It's slow, and especially when you're in an exam situation, it just leaves more variables for you to mess up, essentially. So I use this method here, and utilizing the chart. A lot of people that I've shown this to has always, they always say, oh yeah, that chart's great, and it really makes subnetting fast, but you're not going to have the chart in a testing situation, because you can't just carry this chart in on a piece of paper, right? And they say, because then all your subnetting skills are for waste because you don't have your chart. Well, towards the end of the video, I'll actually show you how to recreate this chart. It's very simple. There's a pattern to it, and I can show you a method to where within about 10 minutes of practice, you'll have that chart memorized and be able to write it for the rest of your life. So I don't know about for the rest of your life, but you know what I mean. So let's go back to our example here. We have the network 192.168.3.0. It's classful, Class C private network. And we have a default mask of 255.255.255.0, right? Now, some of you that's been doing some Net Plus studying out there know that that's not the only way to write a subnet mask. That's actually the long way. That's in dotted decimal format. And basically is what this means is there's three chunks of 8 bits with ones, and then 1/8 chunk of zeros. So there is 24 ones and a 0. The more efficient method to write it is a /24. You might have seen it wrote out like that, which basically means there is 8, 1, 2, 3, 4, 5, 6, 7, 8, 1, 2, 3, 4, 5, 6, 7, 8. Did I get 3, 4, 5, 6, 7, 8? So basically there's 24 ones followed by 1, 2, 3, 4, 5, 6, 7, 8 zeros. Now /24 just tells you that there's 24 ones. It's just a more efficient way of writing the 255.255.0, and also saying it. /24 is a lot easier to say than 255.255.0, right? So if we got /24, now here's the first lesson on this chart over here. So this chart does multiple things. One thing that it does, well, first off, let's kind of get acclimatized. Let's see. We have our subnet line, our decimal line, and our 3 octet lines. Now, one awesome, powerful thing that this chart does is it will rapidly convert a dotted decimal to a CIDR / notation, or vice versa. And the way we do that is we find the first number that is not a 0 going from the right, because remember, a subnet mask is a continuous string of 1s followed by a continuous string of 0s. Has to be continuous. So these are always going to be continuous 1s, continuous 0s. So starting from the right, we're going to find the first octet that does not have a 0 in it. And for this case, it's the third octet. And we represent octets by first octet, second, third, and fourth octet. Now, the third octet is the first octet that does not have a 0 in it. Now, it's not always going to be 255. You'll actually, once we get subnetting, it'll change there. So, going over to our chart, the third octet has 255, so I just found in the octets group right here, third, and then I went to the subnetting line with 255, and if you actually combine those, you get /24. So it's pretty amazing. So like the default subnet mask for class A, 255.0.0.0. Well, that's not a good example. Let's do the 255.2, horrible 255.0.0. Now we have our default subnet mask. Think about what class that default subnet mask is for. It's class B, right? Because we have our first two octets is the network portion, the last two is the host portion. So let's see, we've got octet 1, 2, 3, and 4, 0, 0. The second octet, so right here, second octet is 255. That means we're looking at a /16. The reason /8 doesn't work is because you can't have a CIDR less than /18. There are some instances in like routing tables and such, but as far as just assigning it to devices, you can't go any lower than a /8. But let's get back to our example here. Actually, let me check out something real quick. Make sure I'm not actually just talking to myself here. So if you're actively watching, just go ahead and type up in the chat window, so I kind of know who's watching. All you have to say is, "Hey, how's it going?" But anyway, back to this. We have this address, and we want to split it into two, right? Now, the way you split it into two is you actually have to borrow bits from the host portion of the subnet mask. So what do I mean by that? Right now we have 24. Let's get a different color. We have 24 ones followed by 8 zeros here. Now, to split this network in twos, we actually have to change our subnet mask, and we have to borrow bits from this host portion. So we're actually going to change the subnet mask. And a really quick formula to figure out how many bits you need to borrow is just this simple 2 to the n equals number of networks, number of nets, or actually should have wrote subnets, right? So because this is one network, and we're going to sub-network it or subdivide it into multiple subnetworks. Now we have 8 bits to play with here, and let's look here. So if we do 2 to the 1, what's 2 to the 1? So if you get it out a calculator, 2 to the 1 is 2. So that'll give us 2 networks. Let's say, for example, we needed 8 networks. So 2 to the 3 is equal to 8. So if we borrowed 3 bits from the host portion, that would actually give us 8 networks. But for this first example, we're just going to go really simple and go 2 networks. So 2 to the 1 is equal to 2. And the n in this formula, it's actually so simple, it's not even worth the label of a formula. But the n is how many bits we need to borrow. So the n equals how many bits we're going to borrow. So 2 to the 1 equals 2. We're going to borrow 1 bit. 1 bit from there. Now, I'm going to go back to our question, and it's actually easier to, when you're subnetting, the first thing I always do if I'm presented with a dotted decimal format is I convert it very quickly to the CIDR, because it's a lot easier to read, right? Utilizing the chart, 3rd octet 255/24, right? Sometimes they'll give you the /24, sometimes they'll give you the CIDR, but let's just pretend we got the CIDR. So that means we have 24 bits in the network portion, and we have 8 bits in the host portion to play with, but we're going to borrow one of those bits, and we're actually going to change our subnet mask. And so if we borrow 1 bit, that's going to make our new network portion /25. All I did was just 24 plus 1 borrowed bit equals /25. And then we're going to utilize that new subnet mask to actually write out our new net IDs. So let's do network number 1, network number 2, because we're dividing this network into 2. Now, the first network always is the network you start off with. So 192.168.3.0. Now, here comes the power of the chart. We have a /25 address. So we're going to find that in our chart. So here we've got our 25 in our CIDR field here. So that's going to tell us our 4th octet is going to increment by a decimal value of 128. That's what that decimal field is for. Let's okay. Now our network portion is going to stay the same. So 192.168.3.0 plus 128 equals 128. Now you might be thinking, well, this is kind of easy. It's going to get a little bit more difficult when we split it into more networks, more than just 2 networks. But you know, this first example is we're just kind of getting our feet wet a little bit and just splitting it into 2 networks. Then we'll up it to 4, 8, you know, and then so on. So now that we have our net IDs, we can come up with what I like to call the big 4, or the 4 pieces of information that you actually need to troubleshoot or administer or implement these subnets here. Because the end goal here is to actually, you do all the math, and then you go out and you either statically or using DHCP, you sign out these IP addresses to actual devices. So actually, let me pause real quick. We're looking at subnetting and through the eyes of kind of like a network designer. Later on, we'll switch gears towards looking at it like a technician. As far as here, we're presented with a network, and then we're subdividing it out or subnetting it out. And later, we'll do some scenarios to where you have an existing subnet, and then you have to troubleshoot some issues. That's that's more realistic. So that's more what you're going to do in the field and also the exam. I see all the time people posting on Reddit, took my Net Plus exam today, didn't have a single subnetting question. Very rarely will CompTIA ask you to do what I'm doing here. It's kind of outside of the scope of the exam. They could, but very rarely. It's more on the technician side. So most people get subnetting questions, but they really don't even know that they're getting subnetting questions. Let's see. All right. Live chat. All right. So the big four. The big four is the network ID. Yeah, I don't like making things colorful. So let's do nice blue. So the net ID, the first usable, the last usable, and the broadcast. And the reason I call that the first usable and the last usable is because this net ID and broadcast actually cannot be assigned to any device, right? The broadcast is an address to go out to everybody on the network. So you can't assign that to individual device like a printer, PC, server, because that's an address to address everybody. So it's kind of assigned to everybody, but not really. The net ID is what routers use to get the message from one network to another, right? So it's used in routing tables and routing. So that kind of addresses the whole network as a whole, so that can't be assigned. So the first usable and last usable is a range of addresses that can actually be assigned to a network. And our net ID is already found out for us. That's what we did right up here using our increment or our decimal value. So I'm just going to pull our net ID. So for our first network, for network number 1, our net ID is 192.168.3.0, right? Same as our starting off network. That's a little tip is your first network is always going to be your starting off network. Now our first usable is going to be our, here, let's, different color here. First usable is going to be our net ID plus 1. Now, remember that the IP address is a 32-bit binary number, right? So plus 1, we're actually adding 1 to the end of that IP address. So that would look something like this. 192.168.3, right? Because we're working in that 4th octet, because the /25 tells us the 4th octet. So if we were doing a /29 or /19, we would be doing it in the 3rd octet, but we're not. We're working in the 4th because we have a /25. That's our new subnet mask. So this one, we can actually trash that one. And then plus 1, just going to put a 1 there. Horrible 1. So we're going to just put a 1. Now, the next piece of information I like to find is the broadcast address. Now, the broadcast is the next networks or subnetworks net ID minus 1. Now, what do I mean by that? So our next network here is 192.168.3.128. If we minus 1 from that, that's .127. Or it would look like this, 127, right? And then our last usable is our broadcast minus 1. Broadcast minus 1 is our last usable. So that would be 192. And this is our broadcast address here, 192.168.3.127. So 192.168.3.126. All right. So that's network number 1's big 4. I like to call it big 4 information. So we can go ahead and place that right here. And now we're going to work with network number 2. Wish I could draw a straight line, right? So let's see if I can select this. So what's our 4 pieces of information going to be? Right? We're going to have our net, first, last, and our broad. So first usable, last usable, net ID, broadcast. Net ID was already found for us, right? First usable, kind of think about what it was the net ID plus 1, right? So now this is a different subnet. So our first usable, 192.168.3.128 plus 1 is 129, right? You're probably thinking to yourself, is subnetting really this easy? Yes, it is. So broadcast is going to be the next network or subnetwork minus 1. Now, we only have 2 networks. So what's our next network? Since we ran out of subnetworks in this network, it's our very next network. So 192.168.4.0, right? So each octet in an IP address is kind of like a car odometer, except for going up from 0 to 9, it goes 0 to 255. So once this last octet here gets to 255, it rolls back to 0, and this octet becomes a 4 to denote the next network. But our next network is this 192.168.4.0. So that's going to, let's make some room. So our broadcast is going to be 192.168.3.255, or that last pi piece, right? So if I bring up our /25 circle again, here, let me bring up our /25 pi circle, right? It's this piece right there. So it's kind of the same color, but that piece right there. All right. Now, our last usable is 192. Well, first off, kind of think about what did I say the first time what our last usable is. It's the broadcast minus 1, right? So our broadcast here is 192.168.3.255 minus 1 is 192.168.3.254. And here we have the big 4 for our second network. So we can go out and we can utilize these numbers and actually start assigning to devices, whether that's through DHCP or statically assigning. We're going to assign them. Now, one thing that I kind of skipped over is how many usable addresses per subnetwork. Now, kind of think about what our equation was for the finding out how many bits we need to borrow for the network, there's a similar, also very similar or very simple equation to find out how many hosts is going to be per network. And that is 2 to the h minus 2 is equal to number of hosts per network. All right. Now, if we have a /25, and if we subtract 32, because there's 32 total bits, there's 25 ones in this subnet mask, or 25 ones, 25 bits in the network portion, 32 total, 25, that's 7. So there's 7 host bits in both of these networks, right? So 2 to the 7 minus 2 is equal to 126. So if we were to count from 1 to 126, there would be 126 usable IP addresses, right? 129 to 254 is 126 usable addresses, right? All right. So we're coming up on an hour. So let me know in the chat room. There's about a 30-second delay, but let me know in the chat room if you want me to keep on it going and show another example. So I'm gonna take a quick little break, but let me know if you want me to do another quick example. All right, no one responded, but since I don't have anything else to do today, I'm going to go ahead and continue on and just do another quick example. And I can just utilize this video later on to kind of come up with something a little bit more permanent, a little bit more organized. So let me know how I'm doing so far, just so I know if people are getting lost or what. Not really getting it much response, but let's keep going. All right, let's get another simple example here. Let's get just let's throw a Class C network address up here with the default class /24, and let's say that we want to split this network up into, so now we have one full network, 256 addresses. Now let's say we want to split it up into maybe four networks, right? So we want to take that full network and split it up into 4 different networks here. So if you were watching the last example, what's the first thing that we want to do here? What do we want to find out first? First thing we want to find out is the net IDs of all 4 of those networks, right? So network number 1, 2, 3, and 4. I don't know why my phone is acting up here. Yeah, just let it leave. All right, so we need to find out the 4 net IDs. And if you're watching before, what did I say the first network is always? The net ID for the first network. It is the starting off net ID, right? Or 194.123.3.0. Now we need to find the net IDs for the network 2 and network 3 and network 4, right? So we're going to go back to our chart here, and we have a /24. We need 4 networks, right? So how many bits do we have to borrow from the host portion? And just as a little reminder, 2 to the n equals number of nets. Not number of number of nets, right? Where n is the number of borrowed bits, right? So 2 to the 1 is going to give us 2. So that won't do, right? That's just going to split it in half. So 2 to the 2 is going to give us 4, right? So yeah, that'll work there. So we need to borrow 2 bits. So 2 bits need to be borrowed from that subnet mask. So if we have a /24 plus 2, because we're taking it from the host portion, right? We've got 8 bits in the host portion. So /24 plus 2 is going to give us a new subnet mask of /26, right? So what do we want to do next, right? So we've got how many networks we need. We got how many bits we need to borrow. We already know the first net ID, right? Yeah, we need to go to the chart here, right? Find our 26. It's going to tell us our 4th octet. It's going to increment by 64. Sorry. So /26, 4th octet, increment by 64. Now, just as kind of a little review, what do you think our subnet mask is going to be, right? Well, in dotted decimal format at least, right? So last time I took a dotted decimal subnet mask and translated it into a CIDR subnet mask, right? You can do the opposite, right? You can find out the dotted decimal from the CIDR from this chart, right? And remember, we use this line right here, this subnet line. And the subnet line tells us 192, right? 26 lines up with 192. And it lines up with the 4th octet. So that means our 4th octet is going to be 192 in our subnet, right? Remember 4, 3, 2, 1. And remember, continuous string of 1s followed by a continuous string of 0s in binary format. So if you wrote out 192, it would actually be 1, 1, and then 1, 2, 3, 4, 5, 6 zeros right there. So it is continuous string of 1s and continuous string of 0s. Doesn't look like it wrote out in decimal format, but it is. So let's get rid of those. And if it's a continuous string, so that means the first octet, 255, second octet, 255, third octet, 255. So now if you're going to assign this to like Windows PC, boom, you got your subnet mask right there, 255.255.255.192, right? So let's get back. Kind of skipping around a little bit, but It's good to kind of do some reviews like that. Now let's get back to our incrementing, right? 4th octet by 64, right? So if our first network is 194.123.3.0, then our next network is going to be 194.123.3.4th octet by 64, right? 4th octet by 64, 64, right? 0 plus 64 is equal to 64. Now, third network, 194.123.3.64 plus 64 is going to give us, you guessed it, 128, right? And then our last net or subnetwork is going to be 194.123.3.128 plus 64, 192, right? It's going to be our 4th network. Now, to the fun part. The big 4, right? The big 4. Just like a Jeopardy category there. All right. Now, what was our pieces of information, right? Net, first, last, broad. Net, first, last, broad, right? Let's pick a network. 3. Let's pick network number 3. And let's work out the big 4 for network number 3. Why network number 3? Just because I felt like it. We could do the same for network number 2, 1, 4, whatever, but let's just do network number 3. So our net ID, we already figured that out, right? That was our first step. 123.3.128, right? What was our first usable? Remember, like I said, the first usable is the net ID. So net ID plus 1, right? So our first usable is 194.123.3.129, right? Just add 1 to that net ID. Now our broadcast is going to be our next network. So boom, next network, net ID minus 1. So subtract 1 from that 192. And that will give us 194.123.3.191, right? So if you can add 1 and subtract 1, you can do subnetting, essentially, utilizing this chart. Now, our last usable is just going to be our broadcast minus 1, right? Broadcast minus 1. So 191 minus 1, 190. Right? 194.123.3.190. So there we go. That's our big 4 for network number 3. And once again, why did I do network number 3? Just because I felt like it. Right? So now we can go out and actually implement this subnetwork. All right. So I think we've covered enough for today. Kind of got our feet wet a little bit on this, on utilizing the chart method for figuring out subnets. I think I'll do a session tomorrow, and we'll talk about how to actually implement this in a troubleshooting or a technician style. So give people time to watch this video and kind of get their feet wet on utilizing this, and then tomorrow we'll just dive right in to that. But I did promise that I was going to show you how to recreate the chart for an exam, and so that'll be the last thing that we do today, and then I'll go ahead and sign off, and you guys can subscribe and tell your friends and do all that good stuff. All right. let's the first thing I like to do when writing the chart down for exams is I start off with that column right here. And that first column, I just do a 2, 3, 4. Right? You can write second, third, fourth, but I normally know what 2, 3, 4. And then sub, let's keep the color code maybe orange a little bit. Let's save that color. All right, so, and then sub, and then let's do it in white decimal, right? Now, throw some dashes there. Now this field up here is just a 3 by 8. So 1, 2, 3 by 1, 2, 2, 3, 4, 5, 6, 7, 8 grid of numbers. Starting at 9, going all the way down. 9. Here, let's move this off to the side. So 9, 10, 11, 12, 13, 14, 15, 16, right? So I did 8 numbers. 17, 18, 19, 20, 21, 22, 23, 20, ooh, that's not a 20, 24, 25, 26, 27, 28. Exciting. Counting. Right? This is what you want to do on your Saturdays. Listen to me count up to 32. All right. So now, after I do my 3 by 8 grid of 9 to 32, I drop down here to the decimal. Now, if you've ever done anything binary, you've seen this sequence a million times. Normally it goes further, but just for this chart, we just go up to 128. So you just start at 1, and you just keep doubling. 2, double 2 is 4. 4 times 4 is 8. Actually, no, 4 times 4 is 16. 4 plus 4 is 8. 8 plus 8, 16. 16 plus 16, 32. Kind of get the hang of it, right? 64. 1, 2, 8. Let's see if I can squeeze that in. There we go, right? Hopefully when you draw it out for your exam, it's a little bit neater than what I'm doing, but you get the point. Now, I carry 1, 2, 8 up to the top here. Now here comes the kind of the tricky part. This is the hardest line to replicate, but if you notice, 1, 2, 8 plus 64 is 192. 192 plus 32 is 224, right? So you're just adding the diagonal, and it just gives you the next number. So 128 plus 64, 192. 192 plus 32, 224, right? 224 plus 16, 240. 240 plus 8, of course, 248. You get the point by now, right? 252. 252 plus 2 is 254. 254 plus 1, 255, right? You do that a couple times, and you get the hang of creating this chart. So anytime I go in for a networking exam or just about to teach subnetting or whatever, I just go ahead and just scribble out this chart real quick on your dry erase board or whatever scrap of paper they give you, right? And yeah, so my hand is starting to cramp up a little bit from writing on the drawing pad here. So I'm going to go ahead and sign off. So before you take off, here, let's see if I can draw this out. So before you take off, don't forget to subscribe below, right? There's going to be a little button that kind of looks like this. There's going to be a little triangle, right? Probably in the center is going to be all white. And this is going to be all red, right? Subscribe, share this video, let your friends know about it. So there's going to be more to come. You can look up the Subnetwork on Twitter, and I'll be posting future times and dates on there. Also, very active and becoming very active in the CompTIA subreddit, CCENT, CCNA. So I'll be posting times and dates on there. Hopefully, I get a reminder out a little bit quicker next time. But yeah, so. And it's always going to be recorded. I'll leave it up on my channel just in case you miss it. You can always go back. And yeah, don't hesitate to send me a message and ask a question. Like I said, probably starting next week, I'll be doing like a daily question. I'll throw a simple subnetting question up. You'll be able to pause, maybe work it out on your own, then hit play again, and then you'll watch me solve it, and you can go ahead and check your answers. So just be watching out for those, maybe next week or the week after. And yeah, don't forget to like this video and subscribe. Thank you for watching.